Okay, you should be on page 19 in your journal, and this is where we will record our notes for our 3 physical states of matter. Okay, so all matter can be classified. That's our big word, classify. So classify, remember, means I can put it into groups based on some characteristics, some property they have in common. Okay, so all matter can be classified as either a solid, liquid, or gas. Okay, so you may want to pause the video right now to make sure you get page 19 set up. And don't forget, we also need to put our date. So today is the last day of September, 9/30/13. Okay, and make sure your page 19 is also horizontal, that you turned it sideways. Okay, so go ahead and press pause. When you're ready for the notes, go ahead and press play. Okay, so this is what your foldable should look like on the outside. Now we're going to flip it to the inside. So you should have, and you can draw this line, you don't have to, but we're going to have 3 sections. So here's solid, here's liquid, here's gas. So we're just going to take a couple of notes on the difference between our 3 states of matter. Okay, so if you remember here, the shape and volume of a solid stay the same. Okay, so the shape and volume stay the same. This is for a solid. Okay, now for a liquid, do you remember the difference between a liquid and a solid? Okay, so remember the volume, so that's the amount of water, stays the same, but it will take the shape of its container. Okay, so the volume will stay the same, but the shape will change because the shape will take the shape of the container. Okay, and then our gas is the one that's crazy. So the shape and volume can change. Okay, so those are our notes on how the shape and volume either change or stay the same between the 3 states. The one other note we want to talk about is the molecules or the particles inside. Okay, so the molecules in the solid are tightly packed. Okay, then in the liquid, remember, molecules can slide past each other. So they're loosely packed. Okay, there's a little bit of movement, a little bit more than solid, but not a whole lot. Okay, then in a gas, molecules move around freely. Okay, so they can move around a lot in a gas. Okay, so what I want you to do right here is I want you to give me 1, 2, 3 examples of a solid. Then I want you to give me 3 examples of a liquid. And then I want you to give me 3 examples of a gas. Okay, this part you're going to do on your own. So think about what we talked about for the difference between a solid, a liquid, and a gas. And then I want you to write 3 examples. Once you have your 3 examples, go ahead and press play again, and then we'll pick back up. Okay, so we have our notes on the inside, so you should have your definitions, you should have some examples, and now we're going to flip back to the front. On the front, we're going to draw a picture, but our picture is going to show the molecules. So for example, I'm going to draw an ice cube. Now it may not be the best ice cube. Okay, I'm also going to write that this is ice. My do this. I'm going to show the molecules. So the molecules in a solid, like you said, are really tightly packed together. Okay, so when I draw them, I have to draw them very, very close together. Okay, so there's my illustration of a solid. Okay, so then the next one I'm going to draw is a liquid. So here's a cup of maybe orange juice. Okay, so here's my liquid. I'm going to put that it's OJ. You don't have to draw the little cloud around it. I just like to. Here, our molecules are still pretty close together, but as you can see, there's a little bit room for them to slide past each other. Okay, now our last one is a gas, and I think I'm going to draw a balloon, because what's inside of a balloon? Very good. And I'm going to put helium, because that is what the gas is called inside of a balloon. Okay, so here my particles can move very freely around. Okay, all right, so those are our three physical states of matter. Okay, the next thing we want to know is that we can go from solid to liquid to gas. Okay, my ice is not going to necessarily stay as solid. My liquid, if I have liquid water or liquid orange juice, it can change to a solid or to a gas, can't it? Okay, so what we want to do is we want to just take a couple quick notes on the properties of water and how water can change from a solid to a liquid to a gas, or a gas to a liquid to a solid. Okay, so now you need to be on page 20. Okay, and you should have this handout from class today, and again the date is the 30th. Don't forget to be making sure you're putting these entries in your table of contents. Our title's properties of water. Like always, you can keep this title, or if you want to cut it off and write your own, you can. Okay, real quickly, we want to talk about water. When we think of the three states of matter, solid, liquid, and gas, the easiest way to remember how matter can change is by thinking of water. Okay, you know water can be ice, you know water can be a gas as water vapor, or it can be just like the liquid water you drink. Okay, so three important things you're going to need to know is the boiling point, the freezing point, and the melting point. Okay, that's one property of water. Okay, so water has a certain temperature that it's going to start boiling at. Water has another temperature that it must reach before it will freeze, and then water has another temperature it must reach before it will melt. Okay, so the boiling point, that is 100 degrees Celsius. And remember, in science we always talk about Celsius. And these are numbers that you're going to want to have memorized. Okay, and remember, think about what happens when you boil. If you're at home and your mom or grandma or dad is boiling a pot of water and they put the water on the stove, they turn the stove on, eventually that water starts to bubble. Okay, so I am going, sorry about that, I start with the water, correct? And then I go to a gas. So my state of matter change is going to be liquid to gas. Okay, so boiling point is 100 degrees Celsius. When water reaches 100 degrees Celsius, that liquid is going to change into gas. Okay, now let's look at our little thermometer here. And if you have a red, you can even use marker here. If you have a red marker, crayon, or colored pencil, or even a pen, I would prefer that you use that color on this graphic organizer. Okay, so we just said the boiling point is 100 degrees Celsius. So I am going to color in my entire thermometer because it has to reach all the way to 100 degrees Celsius before it will start to boil. Okay, so that is the boiling point. My next property of water is the freezing point. Okay, so let's pretend like some liquid's at 100 degrees and then I take it off of the stove and I put that water in the freezer. That temperature is going to start going where? Down. Very good. Okay, so water is going to have to reach 0 degrees Celsius in order to freeze. Okay, and when you put it in there, it's there as a liquid. So I put it into my freezer as a liquid, so it's going to start off as the state of matter known as liquid. Once the freezer reaches 0 degrees Celsius and that water gets to 0 degrees, then it's going to change into what state of matter? Very good. It's going to turn into ice, which is a solid. Okay, now here, if this is 100, you've got to know how to read this. So here, right here, is going to be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So right here is 0 degrees Celsius. So all I'm going to color in is the little very bottom part of my thermometer. Now, we've talked about 2 ways for our water to change. The last property of water is what we call the melting point. Okay, so let's pretend like we have ice. Okay, so we have boiled our water, we've now freezed our water, we now have a solid. I take that ice out of the freezer. Okay, the temperature is going to, I'm sorry about that again. The temperature is going to start going where now? Up. Very good. Okay, so it was in the freezer, it was really cold. I take it out, the air around it's going to start warming it, and so the temperature is going to start rising. Okay, this is a part that a lot of people find confusing. The melting point of water is also 0 degrees Celsius. So if you notice, that's our freezing point. The freezing point and melting point are the same. It just depends on if the temperature is getting warmer or if the temperature is getting colder. So when I take that ice out of the freezer and it starts to warm up due to the air around it, once it reaches 0 degrees Celsius again, then that solid ice is now going to turn back into what? Water. Very good. So it's now back as a liquid. Okay? And like we said, it is 0 degrees Celsius, so my melting point and freezing point are going to look exactly the same. It just depends on if the temperature is rising or falling. So I take my water and I put it in the freezer. Once it decreases down to 0, then it will freeze as a solid. If I take that ice out and I put it in room temperature, once that temperature rises to 0 degrees Celsius, then it will melt. Okay, so what I want you to do is I want you to think about what we just learned, and I want you to answer this question for me. And you notice you have quite a few lines. I want you to put some thought into it. I want you to give me evidence. I want you to think about what I just talked about. If you need to rewind it and replay it again, please do. But I want you to think about why the freezing point and melting point of water might be the same. Okay, so rewind the video, listen to it again, give me a detailed explanation, give me evidence. Okay, don't just say because they're both 0. Okay, that's not a good scientific explanation, because yes, they are both 0, but I want to know why. Okay, and if you need to do some research on the computer, you are more than welcome to do that as well. But that is all of the notes for today. Thank you so much for doing your homework, and I will see you in the morning.